Welcome everybody to our live session from June 9th. And today we are going to be working on the items in 4.7 of our Python unit, which are lists and dictionaries. And they are extremely important if you're going to code in Python or frankly any other language. All languages will have some form of lists or dictionaries. And the reason that they're really important is because they're the primary method that we use to store data inside a program. Now, as you take, Computer Science 30 or perhaps secondary training in university or a tech school or something like that, you work a little deeper into the languages, you'll start storing things in databases outside of your Python program or on Word documents or text files or all sorts of different storage media. And programs are a very limited value if they can only work with the data that you have within the one program, and so extending that functionality to allow you to store large pieces of data or media or basically anything outside of a Python program and then access them from the outside program and bring them in to do certain things, it becomes very valuable because essentially you have unlimited storage of those things outside of the program, and you can kind of just grab and work with what you want at any given time. But that's digging a little deeper than we're going to do in Computer Science 20. In Computer Science 20, we're just going to work with creating storage places inside our programs, and then making sure we know how to add things to our lists and delete things, and use loops to populate lists and use loops to look through lists for certain items and things like that. So we'll just start with dictionaries because dictionaries will use much less than lists for the remainder of the course, but they are still a pretty important part of Python. So I want to make sure that you're introduced to them. So starting with dictionaries, dictionaries, well, they're named that essentially because they are very similar to a traditional paper dictionary that you might find on the shelf at school or at your house. And that is, when you reference something in a dictionary, you're looking up a certain word, and when you find the word in the dictionary, then there's a definition of the word beside it. So there's two pieces of data that are linked somehow. It means something to each other. If I look up the word tremendous, I know what I'm looking up, but I don't necessarily know the other part of the equation. But if I know the first part, the word, then I can find the other part, which would be the definition for the word tremendous. And in Python, it works in a very, very similar way. Starting instead of having a word and a definition inside of dictionaries in Python, we refer to them as keys and values, and in that order. So if you were to use the offline dictionary example, the key would be the word that you're looking for, and the value would be the definition of the word. So it works in the same order in Python as it would in a paper dictionary. This is how you create a dictionary. So you have to use this syntax. I've got mine named myDI, but that's just a variable name, or that's just a name for the dictionary. You can call that whatever you want. So I just made a new dictionary and called it myDI. So you have to have myDI equals, and then this might be new because we haven't used this yet. This is called a brace. It's basically a curly bracket, and it's available on the same key that's got the square brackets that we've seen before. You're just going to have to hit Shift to put in one of those curly braces. So dictionaries rely on curly braces, whereas lists rely on square brackets. So that's one of the main differences when you're starting a dictionary or creating one. So they start with that curly brace, and then you have the key listed first, then a colon, and then the definition or the value listed second. And then a comma separates each of the items in the dictionary. So for instance, this would be the first word, the first definition, and then comma. This would be the second word, the second definition, and so on. You could store as many items as you want in a dictionary. I just created a very small one here with 3 items because we don't need any more than that to demonstrate all of these skills. Okay, so what all this dictionary does is it's just showing an English word, and then the definition is going to be the Spanish word. So 1, the Spanish equivalent would be uno. 2, the Spanish equivalent would be dos. 3 would be tres. And you could keep going on forever. But the important part is that you understand that the key is the first thing, and then a colon, and then the value is the second thing. I've used strings here, but you could also use You could also use numbers on the second side. So you could have that equal 6 or 6.6 or something like that. But the vast majority of time when you're using dictionaries, you're going to be using strings. So that's why I've used strings for all of these. And when you're at the end of the dictionary, you just put another curly brace to indicate that it's done. So we went through these two parts, indicating which one of these is the keys and which one is the value. And now we're going to move on to our next step. I'm just going to copy this down as we work down the page. Okay, so we know how to create dictionaries, and you should have lots of examples of that in your learning materials, as well as right in front of you right now. How do we add elements from a dictionary? How do we delete items or elements from a dictionary? It's pretty simple, actually. If I wanted to add another item to this dictionary, all you need to do is you need to start out with the dictionary name, so whatever you named it, and then you're going to have to say, square brackets, and then you put the key in here. So let's say I want to do the number 4. I would say my DI square brackets. Okay, now that's a little strange because we notice when we're starting the dictionary we include the curly brace, but now when we're trying to add something to the dictionary, we use the square brackets, and the reason for that is that's how it identifies where in the dictionary to find something. So if you see the square brackets, we're essentially saying you need to look for a key that's 4. Now, 4 doesn't exist right now, so if I put my DI and then 4 inside the square brackets, and then I put whatever the value is, it will automatically add it to the dictionary because I've indicated which dictionary I want to work with, which is my DI. I've indicated a key, which is 4, which is new, and then I'm also going to indicate what the value for that key should be. And I got to think here, what's Spanish for 4? Uno, dos, tres, cuatro? Cuatro.
Oh, this is like less.
Cuatro. That's definitely not how you spell it, but something. Uno, dos, tres, cuatro, cinco, seis. Okay, we'll just assume that, we know that my Spanish is clearly terrible, but we're just going to assume that cuatro is the Spanish word for 4. So when I've indicated the dictionary, the key, and then equals the value, when I print out my dictionary again, you should notice that the 4 and cuatro has been added to the end of it. So my DI, I'm going to print out my DI. Okay, now you look at the dictionary that it printed out down here, and it's got 1, uno, 2, dos, 3, tres, 4, cuatro. And so clearly it has added 4 to the back of my dictionary, and all is well. I also might print out the original dictionary up here just so we can see how it is changing based on what we do. Yeah, no worries, Nathan. Oh, sorry. So whenever I make these changes, we'll be printing out the original dictionary as well as the new version, just so we can show how things are changing. So that's how you add items to a dictionary. You can add as many as you want. Just do them with separate lines. You could add 5, 6, 7, whatever you want to add to it. And now we're going to look at how do we delete an element from a dictionary. And it's a little different than adding. So when you delete an element from a dictionary, what you have to do is you have to use the del keyword. Del is sort of a standard delete function that's built into Python, and it works for some data types, and it doesn't work for other data types. So it does work for dictionaries. So if I want to delete an item from a dictionary, what you need to do is you need to type in del, and then you need to type in what the dictionary name is. So in this case, I named my dictionary my DI, and then you have to delete using the key for the thing you want to delete. So if I want to delete the 2 dos entry for the dictionary, I would put 2 in here because that's the key. So it should access the key that matches up with 2, which is right here. And then when it recognizes that, it's going to delete. No, Nathan, it's 11:59 p.m. tonight. Hopefully that clarifies it for you. Sorry, back to what I was doing there. Oh, so we're deleting, looking in my dictionary, looking for the key 2, and then it's going to delete the entire entry. So it's going to delete both the key and the value from it. And then when I print it out again, you should notice that the 2 item or 2 dos item is now gone from the dictionary. So print it out again. Working with dictionaries sometimes causes PyScripter to slow down a little bit. I'm not sure if it's the same thing in Thonny, but if that happens, don't worry about it too much. It's just maybe a little buggy when it comes to dictionaries. So I ran it again, and you'll notice the first thing it printed out is the original dictionary, and then the second line underneath that it shows the dictionary after we added 4 quattro to the end of it, and then the third one is when it's printed out after we removed the item for 2 DOS. So original, add 1, and then subtract 1. But obviously, you can add or subtract whatever you want. If I also wanted to delete my DI, let's say I also wanted to get rid of 3, you can do that as well. It'll get rid of as many as you want. I believe you can do that in one line too. I just want to check. If you put a comma, I suspect that it'll also delete the items, but we'll just confirm that right now. So I del my DI and then comma my DI 3. Hopefully it gets rid of both 2 and 3, but I can't remember if this works or not. It does. So you don't necessarily need to use 2 lines. You can just use 1 line and keep telling it what to delete, and it'll delete them all at once in 1 line. It's also no problem to do it in 2 lines. So that's how you add elements. That's how you delete elements. And printing works the same way that printing normally works. You print brackets and then just put my DI so that it knows what to go to print. And it prints it out so that it looks like a dictionary. You notice it's got the braces and the quotes and the commas and the colons, just like it does up here. So when you ask it to print a dictionary, it prints it in that format as well. All right, next, accessing and printing values and accessing and printing keys. It's a lot easier to print the values, so essentially the definitions, or in this case, the Spanish versions of the word. It's a lot easier to print those than it is to print the keys. And I'll show you how we can do both of those, but you also see that printing out the values is a little easier than printing out a single key. So if you want to print out a single value from my dictionary, you just have to print it and refer to that particular key. So if I want to print something from my DI, I'm going to start with print my DI, and then in the square brackets, let's say we want to print the Spanish word for 2. So you would have to put 2 inside the square brackets. And then what it does is it says, I need to print something. So what do I need to print? I need to go to my DI, and I need to access whatever value is associated with 2. So if we look at our dictionary, the value that is associated with the key 2 is dos. So all this is going to do is going to replace this entire chunk with dos, and that's what it's going to print. So if I run it, you'll see that it just prints dos down there. And you can include this with, with any number of other things that you need to print. You don't have to just print one thing on a line. Remember that you can separate anything that you want to print with commas. So for instance, what if I say the value for 2 in the dictionary is, and then I can put quotes and comma, and then I can access my DI2. So it's going to print out the string at the beginning, and then the comma tells it you're also going to print something out on the same line, and then you're just accessing whatever is in that spot in the dictionary. So now it'll print out the value for 2 in the dictionary is whatever. So that's a formatting thing. And by this point in the course, you should probably be getting pretty good at concatenating things for strings, being able to print strings and other stuff in the same line, whether it be floats or Boolean or integers or other strings. So by using the comma is what I use, because it's just the easiest method of combining things in strings. So you'll notice in the print line it now says the value for 2 in the dictionary is dos. So that's somewhat more readable and intuitive than just printing out dos. So that's how you can print out a specific value. You can print out all of the values for the entire dictionary with one command as well. If you just print my DI dot, so it's dot notation, values, and don't forget the two brackets behind values, it will print all of the values in the dictionary. So you see now it printed at the bottom. DICT underscore values is just the Python way of telling you these are all the values inside the dictionary you asked about. In the dictionary I asked about, my DI, This is the complete list of the values. You notice it doesn't have the keys in here. It's only got the values. It's got uno, dos, and tres. So it's printed out the values. Now you could print out all the keys as well with almost the exact same code, just using keys instead of values, and it will print those out as well. And you see now it's printed 1, 2, and 3, which are the keys, 1, 2, and 3. And sometimes that might be helpful, but what if you just wanted to print one value, or sorry, one key? Now we know it's easy to print one value by just printing my DI and then telling it which key is going to be what we use to find the value. So we just use the square brackets. We just did this a second ago. That's easy. So I can just pick whatever value I want and print it out. But it doesn't work the same way if you try to print out a key. So if I try to print my DI, and if I want to print the key for, let's say I want to print the key for dos, which is 2, I can't just put dos in here. Okay, so when I try to print this one out, it gives me an error, and it says, we've got a key error, dos. We can't find the key dos in your dictionary. And that's because there is no key dos in my dictionary. The keys are 1, 2, and 3. So you can't use the exact same method to print out a key as you can a value. We have to dig a little deeper, and the easiest way to do it, I think, is to use a quick loop. So what I would do is I would say for, I'll just use, this could be any variable name. I'm just going to use key because it makes sense for what I'm doing. So I might say for key in my DI. So whenever I use a for loop, it's going to start at the beginning of the dictionary and go all the way to the end. So for key in my DI, and then I'll have an if statement. If my DI, and then I put the key variable behind it, equals dos print key. Now I'm just going to quickly explain what this is doing. Okay, I'm going to get rid of this stuff up here. Our goal here is to just print out 2. And we know we can print out all of the keys by just using the print mydi.keys, but we don't have an easy way of just printing out one key, one specific key. So using a quick loop and an if statement, you can make your life a lot easier this way. So all this is doing is saying for each item in this dictionary, and in this case, this value here is going to start at whatever's at the beginning of the dictionary. So it's going to start at 1. All right. So for each key in the dictionary, if my dictionary and that key, so if my dictionary 1 is what it's going to start with, is equal to dos. Okay. So if the key 1 in my dictionary is going to refer to this whole chunk right here. Don't forget, this is how we access a specific value. So this whole chunk right here is going to start with uno, because I'm asking for my dictionary of the key, and the key is just going to start at the first one and go to the end. So the first time it checks in this loop, it's going to say my DI 1 is actually equal to uno. Okay, so this is going to be false, because my DI key is going to be uno, and we know that that's not equal to dos. So it's not going to execute this print key line. However, the second time it runs the loop, now instead of key being 1, key is going to be 2. Okay, so for 2 in my dictionary, if my DI of 2, which is going to give us the value dos, so if dos equals dos, which is true, it's going to print the key. So now what it's going to do is it's going to print 2, and then it's going to check one last time, because remember, this for loop will go all the way to the end of the dictionary. And the last time it runs this loop, the third time it runs this loop, the key variable is actually going to be the 3 up here. So for 3 in my DI, if the value of my DI 3 is equal to dos, which we know is going to be false, because my DI of 3, or my DI in the 3 slot here, is tres. So tres equals dos. No, that's false. So it's not going to print that key. So essentially, it's going through the dictionary from front to back, checking the keys and values. If the value is equal to the one that you wanted, it's going to print the key out. If it's not going to print. So when I run this one, it's only going to print out 2. See how it only printed out 2? because this if statement was only true the second time through the loop where it was checking this item right here. So if this item, the value of this item was dos, which it was, then it's going to print out whatever the key was. And you could change this right here to whatever you want. You could check this if you wanted to find the specific key and print the specific key for trace. You just change what you're looking for to trace instead of dos, and now it's going to run. And on the third loop, it's going to find the right one, and it prints out 3. And once again, don't forget, a lot of the time, your programs are going to be asking you to combine things in a print statement. So this might be the sort of thing where you would say the key key for the word trace, I don't know, it's trace, is, and then your quotes, and then a comma, and then whatever is currently in the key variable up here is what it's going to print at the end, which in this case is going to be the 3, because that's what we're looking for. So when I run this guy again, now it's going to print out the entire sentence, right? The key for the word trace is 3. So that's how you can print out values in dictionaries, specific values in dictionaries, or all the values in dictionaries. You could print out all the keys in a dictionary, and you can also print out and find and print out a specific key in a dictionary. So that, those should all be very helpful things. And remember, if you can access something, you're not always printing it. Maybe you're using it for math, or maybe you're using it for anything essentially. If you can find it and you can access it to print it, then you can do other stuff with it. You can do math with it if they were numbers or whatever. If you can print something, you can do other things with it. The important part is knowing how to find it and knowing how to extract the data that you want out of dictionaries and lists. Okay, so if we want to do a quick check as to whether or not something exists in a dictionary, that's actually a very quick process. It'll return. There's a quick Boolean statement that'll tell you if something is in a dictionary, and it doesn't matter if it's a key or a value. You could find out very simple. So if I want to print out, and I want to check. Let's just say I want to check if the word dos is in that dictionary. All you need to do is print, and then in quotes, what you're looking for, okay, dos in my DI. So print dos in my DI. So this is actually a kind of a built-in logic statement, and all the in is telling Python to do is take whatever's in front of the in and then check and see if it exists in the dictionary or list or whatever we've got here. So this is not actually going to print dos. It's going to print the value of dos in my DI, which is Boolean, which means it's either going to print true or it's going to print false. So in this case, if it's working properly, it should print true because we can see the value dos right here. So it's not going to print 2, it's not going to print dos, it's either going to print true or false based on whether or not that is in your dictionary. So when I run it, it prints false. Why did it print false? Dos. Oh, I'm sorry, I had it backwards. This checks if keys are in your dictionary. Sorry. So instead of checking if dos is in your dictionary, you need to check the key, which is 2. So I'm checking, is 2 one of these 3 items that are keys in my dictionary? And it should be true because it is in there. So when I run it, this one's checking the key. It says true because it found 2 right here. So I should maybe just put a little note there. You need to check the key. And then if you want to check a value, it's just one slightly different little tweak here. So if you want to check the value, you need to change this to, obviously you need to change for the value you're looking for. So if I'm looking for dos, okay, I need to look for dos, but if I'm looking for a value instead of a key, I have to add one more thing. I have to add dot values in the brackets to the end. So now this tells it to look, don't look at the keys, look at the values when you're checking for dos. So this should also give me true. So you see how it printed true and true because it found 2 in the keys in the dictionary right there. And when I asked it, is dos in the values, it checked all 3 of the values and it said, oh, I found dos, it's right there, so that is true. So remember that when you're using the if something is in something else logic, that it's only going to give you Boolean, it's only going to give you either true or false. depending on it's there. If I check to see if two, the word two, is in the values, it should give me false because two doesn't exist in the values anywhere. The only values we have in the dictionary are uno, dos, and tres. So if it's looking for two on the values side, it's not going to find it, which means it should print out false. So it's going to print out true, and then it's going to print out false because the top one was true, bottom one was false. Okay, so we already looked at finding a specific key, and that is pretty much all you need to know for dictionaries. If you go a little further in computer science, you're going to learn a lot more about dictionaries, but to be honest with you, you're going to use lists or what's commonly called arrays, depending on the language. I mean, in Java, you usually refer to arrays. In .NET, you usually refer to them as arrays. Python, you refer to them as lists, and some other languages too. So when you see the word lists or you see the word arrays, it means the same thing. You're going to use lists probably 100 times more often than you're going to use dictionaries. So that's why I left it to the second thing we went through, because we need to go in this one in a bit more detail, and you're going to be using this for most of your assignments from here on in, and definitely on the final exam with both the theory section and with the practical section. So you need to know your lists well, and we're going to go through everything that you need to know about lists in today's session. So you can refer back to it whenever you want. So a list is just another way of storing data, but unlike dictionaries, there's no value key relationship. It's sort of like a string in that you can access items in a list based on an index number. So in a lot of ways, lists work very similar to strings. Just instead of a string has a certain number of letters and each letter has an index spot. We've gone through that a lot before. Lists store an entire item, and then they also have index numbers as well, so you know which position it's in the list. It's an it's sort of an order thing. So if I just create a sample list, and I'm going to call it my list, unlike dictionaries that use the squirrely brackets, lists use the square brackets. So if I want to create an empty dictionary, I could just put 2 square brackets, and that's an empty dictionary. Or if you want to add stuff to the dictionary right away, all you need to do is separate each item with commas. So the nice thing about lists, and the reason that they're so valuable in Python, is you can store any type of data at all in a list. It doesn't matter what it is. So I can put, let's say I'm storing the number 6, which is an integer. I can store 4.5, which is a float. I could store the word hello, which is a string. I could store Boolean true. Maybe I'll store another word, and maybe I'll store another integer at the end. So just like when you're creating variables, if x equals 5 kind of thing, Python looks at what you've entered in your dictionary, and it assumes the proper data type for these. So it would look at this and say, hey, that's an integer, this is a float, this is a string, this one's a Boolean, and so on. So when you enter things into a list, it doesn't just assume that everything's a string. It actually keeps the data type of the item. And you can also put variables inside of lists as well. So if, let's say I had, I'm just going to create a variable called myInt, and then myInt is going to be 7. I don't necessarily have to add 7 to the end of my list. I can add myInt to the list, and then whenever I change what myInt is, it's going to automatically update the dictionary. When you print a dictionary, it does something very similar. So if I print my list, it does something very similar to what it did with dictionaries. It shows you what the entire list looks like. So if I print out my list right now, you see it printed it out with the brackets and the commas and everything that you saw up here. So when I print out my list, it says your list is containing 6, 4.5, hello, true, hi, 5, and 7. Now you notice how it replaced myInt with 7, because it knew that myInt is just a storage place, and currently in that storage place we have the number 7. If I were to change this to 99 and print it out again, now this is dynamic, meaning it changes, and now it's going to put 99 in there instead of 7 because the value of myInt changed. Now this is really handy when you are asking users to input data, because you can just put whatever the user typed into the list. So that's a really easy way for you to populate lists and store data that a user has typed in. Now we're going to get to that a little later because that's just a bit more complex. The main things here is you need to know how to create a dictionary. And you need to know that you can put multiple data types in a dictionary, because that's very important. And then you need to know that dictionaries work like strings in that they have index numbers, and the index numbers work the exact same way. So I'm just going to get rid of my int right now because I'm not going to use it right now. And what that means is, if we look at my list, 6 is in the 0 index, 4.5 is in the 1 index, just like a string. It's just the position that it's in. True is going to be the 3rd index, high is going to be the 4th index, and as a coincidence, the integer 5 is going to be the 5th index. And just like with strings, negative values work as well. So the first one's going to be negative 1, 2, 3, 4, 5, 6. So this is negative 6. For a second there, negative 6. The next one is negative 5. This one would be negative 4. This one would be negative 3, negative 2. And just like with a string, if you refer to negative 1, it always just goes to the end of the list. It picks the thing that's at the very end of the list. So if I want to access high in this dictionary and print it, or in this list and print it out, I can do it 2 ways. I can print my list and then square brackets again. I can print my list 4, and that should print out high, or I can also print out my list negative 2, and that also will refer to the high part of the list. The only difference between these two is when I use the 4, it's starting at the beginning of the list and looking for the 4th index. And if I use a negative number, it's starting at the very end of the list and then looking for whatever number it is in reverse order. So this should print out high twice because it's really accessing the same container inside that list, which should be storing the word high, or the string high. You see that happened there. So if I were to print out my list negative 1, it's going to go to the very end. Now it's going to print out high, and then it's going to print out 5, because 5 is what I have stored right at the end of my list. So list slicing works exactly the same way as string slicing, which is really handy. So for instance, if I want to print out all of the items in the list from a certain position to a certain index to another index, I can do it the same way as strings. Now, it starts by 0 at default, but remember, if you don't want to include the 0, you can include just a colon, and that can sort of just shorten things for bits. So it assumes that anything on the left side of the colon is the starting point, and anything on the right side of the colon is the ending point. So if you have nothing on either side of the colon, what it's assuming is you just want to start at the beginning of the list and you want to print it all the way out to the end of the list. So all I've got in the brackets right now is a colon, which means it should print out the entire list. So you see it printed out every item in the list. Now let's start slicing it in certain ways. Let's say I want to start at the beginning of my list, which would be the index position 0, and I want to print all the way up until hello. Okay, so I want to print the 0, the 1, and the 2 index, or the negative 6, negative 5, negative 4 index. I've got my starting point on this side, which is 0, and then I have to tell it where to stop. So 0, 1, 2, I want it to print 2, which means I have to make the number 1 bigger, because remember, it stops at this index before it prints what's in this position. So if I want to print out from 0 to 2, I have to actually include 3 as the number to stop at. So it prints 0, prints 1, prints 2, and then stops as soon as it hits 3. So if I print my list, nothing, colon 3, starts at 0, prints 1 and 2, and then stops. So when I run this, we should say 6, 4.5, and hello, and it does. If I want to if I want to start at a certain point and end at a certain point, you use slicing the exact same way as strings. Let's say I want to start at 4.5, and I want to print 4.5, hello, and true. Well, it always prints the first thing you put in there. So I know I need to start at 1. Okay? And I have to be careful about where I'm ending. So if I want to print 4.5, I start at 1. I make sure I include 2. I make sure I include 3. And then I have to stop at 4. I don't want it to print out high, so I need to make sure it stops right when it hits high. Okay, so 1 to 4 should print out these 3 items. Let's see if it does. It does. 4.5, hello, and true is printed out, so this worked properly. And then don't forget, if you leave the second one blank, it'll start where you ask it to start, and then it'll just print to the end of the list. So if I start at index position 3, I'm starting here, I'm starting at true, and then it's going to print all the way to the end. So it's going to print true, high, and 5. Now this is handy, and this is important because if you try to put another number in here and index and reference this last number, for instance, let's say, oh, I'm not thinking, and I say I want to start at 3 and I want to end at 5, and I'm not thinking, and I forget that it's going to stop right here before it prints out the value, it's going to not print out the last part. So you notice it just printed a true and high, because when it got to 5, it just stopped without printing the 5. So this code may look like it's printing everything till the end, but because it stops at 5 and doesn't print what's in the 5th spot, you're actually getting one less thing than you think you are. So that's why you need to know that if you don't have anything on this side of the colon, that it's going to go right to the end of the list, and you're not going to miss that last item. Another handy way of knowing how to add things in a list is understanding that the length of a list can be measured just like the length of a string. So if I want to, create a variable, maybe call it length list, I can always find the length of a list just by using the same process, len, and then in the brackets, you just, whatever list or whatever thing you want to have the length of. So if I type in the length of my list and store that in length list variable, and I print out that variable, it's going to count all the items in the list and then tell me what that is, or store it as an integer in this case. So length of list is what I want to print out. And if I look at my list, there should be 6 things in it, right? So I've got 1, 2, 3, 4, 5, 6 things in my list. So when I print out length list, it should just print out 6. It can't be a decimal. It's got to be an integer. When I print out length list, it should say 6. Okay, and it does. So that's really handy because lists can be changing. You can have you can start with 1 item in a list, or 3 items, or 5 items, but depending on your program, you may be adding to lists or subtracting from lists, and your lists are going to grow in size or shrink in size. So by being able to find the length of a list in any given situation, you can use that to access and print out or use the data that's in a list. I'll give you an example of that right now. Let's say that I always want to print out the first half of the list. Okay, there was something similar to this, only using strings, in the first unit exam practical portion. I think I said I'm going to type in an even length word, and you're going to have to print out the first half of that word. And you didn't know if I was going to type in a 6-letter word or an 8-letter word or a 20-letter word. All you knew was that you have to use string slicing to print out the first half of that word. Okay, so the fact that you don't know how long this list might end up being is going to make that a problem if you always want to print out the first half. It's easy for me to print out the first half of this list if I know there's only 6 items, but if it's going to change to 10 or 20 or 15 or whatever, I'm going to need to use some logic to figure out what the first half is. So if I know what the length of the list is, I can always find out what the halfway point is by dividing that by 2, right? So what I want to do is I'll just create a variable called halfway, and I'm going to say that's going to be the length of my list divided by 2. And I'm going to do it with integer division. You notice I did the 2 divided by signs, not 1, because I can't have a decimal. I can't access index 1.5. It doesn't exist. Index numbers are integers, 1, 2, 3, 4. If I try to access 1.5 or the item in 1.5, there's nothing there. It doesn't exist. It's an illegal operation. So if I divide the length of my list by 2, I essentially find the halfway point and then the way to stop. What I need to remember, and I'll demonstrate this, is that it stops a little before you think it will stop. So if I just print out my list, and then I'm going to use slicing because I want to print out or access more than one thing. I want to start at the beginning, so I'm not even. You could put a 0 here, but I'm not even going to bother. You can just leave it blank. But where do I want to stop? I want to stop at. If I look at the list above, I know I want to print out the first 3 things because it's a 6-letter list or a 6-item list. I want to print out the 6, the 4.5, and the hello. So ideally, if my halfway point, my halfway variable is correct, which should just be an integer, it's going to print out from the beginning to whatever halfway is. And in this case, we'd like halfway to be 4, and I'll tell you why in a second. So let's just look at what this prints out. Okay, so it printed 6, 4.5, and hello. And that's actually what I wanted it to print out. Let me just check what it said my halfway variable is. Halfway is an integer value of 3. And oh no, sorry, 3 is what I wanted because we start counting at 0. That's good. I was a little confused there. Because we start counting at 0, I actually do want it to stop at 3 and not print the third index item because 0, 1, and 2 are all in the first half, and then true, high, and 5 are in the second half. So if it stops right at 3, it doesn't actually print 3. It's printing the 3 things I wanted it to print, which was the 6, the 4.5, and hello. So right there, that is an excellent way, either whenever you're using strings or lists, to find the halfway point in that list, no matter how big or how small your list is. So that's a handy way. And if you wanted to print the second half of the list, all you would have to do is flip the order around here, and you say, I want to print from the halfway variable. In this case, the halfway variable is 3, so that works out nicely. I want to print out from the halfway variable to the very end, and I can just leave it blank on the other side of the colon because we know if there's a blank on the other side of the colon, it's just going to go to the very end. So if I know where the halfway point is, I also know where the end is. I don't have to put a number in. It's just going to start at the right point, and it's going to go all the way to the end. And it doesn't matter if my list has 6 items or if my list has 600 items. This should work. So we managed to use that sort of process and the length command, the len command, to figure out where the halfway point is in any given list. And you can print out the first half. You can print out the second half. You could find a way to print out the middle. If you wanted to divide by something other than 4, or by 2, maybe you divide it by 4 instead, and that'll print out the first quarter of the list and the last quarter of the list instead of halves, right? So, sorry, this would print out 3/4 because it stops late. What's the first quarter of this list? My length, 6 divided by 4 should be 1. Halfway, it's not halfway anymore, but if I divide by 4, that should give me the quarter waypoint. 6 divided by 4 with integer division should be 1, so it should be printing out 4.5. So if I look down here, I'm starting at 1, which is 4.5, and then I told it to go to the very end, so that's going to print out, it's actually going to print out 3/4 of the list, right? Because it's going to start here, and then I told it to print to the end. So it started at 4.5, went to the end. If I flip these around and I start at the beginning and I only go to the quarter point, I know it's called halfway still, I didn't change the variable name. But if I'm dividing by 4, now this should start at 0, and it should print up to the quarter point, which in this case, if it's 1, it's not going to print 4.5, it's just going to print 6. So the math on that doesn't really work out, but it's important you understand what's happening up here. By dividing the length by 4, 6 divided by 4 is 1 point something, so it drops off the point something, and it says, all right, I'm going to start at 0, because you told me to, right here, and then I'm going to stop at 1, which means I stop here, but I don't actually print out 4.5, which means the only thing I printed out was 6. You know, if you divided it by 3, you'd get a few more numbers. Now you'd get 6 and 4.5, and it would stop at 2 because 6 divided by 3 is 2, so it would stop before it printed hello. So string splicing is extremely important because you can access a single list item, a certain number of list items, the first 3, the last 10, something like that. You can cut stuff out of the middle by using slicing, and you can access and print or access and use basically anything you want, as long as you are able to create the logic to find those things. And creating the logic to find those things just takes a little practice working with this list splicing method that we're going through here. Okay, now I told you that your lists can include all sorts of different types of data, and you're not always printing stuff out. I mean, oftentimes you are trying to use that data, for math or to check if something's true or false or whatnot. So be aware that you can not just print stuff from a list, you can actually use it. So let's say I wanted to add the first 2 items in the list together and print that. Okay, so I print, and then my list. I want to print my list. And if I want to use the first two items, there's the first item in the list, or it's the 0th item, but it's at the beginning of the list, which is a 6. I'll print 6 plus my list. And then the second item, or the number 1 index in the list, would be 1. So I'm printing whatever's in my list 0, and I'm going to add that to whatever's in my list 1. So if I print my list 0 plus my list 1, it should go 6 plus 4.5 is 10.5. So I can access stuff from my list and do math with it. So you see how it says 10.5, because 10.5 is 6 plus 4.5. Now I wouldn't be able to also add. I wouldn't be also be able to add my list 2, because now I'm trying to add an integer to a float, which is fine, but then I'm also trying to add a string, and we know we can't add strings to numbers. It doesn't make any sense, right? It gives you that error. Can't add floats and strings. So it didn't make sense for us to add whatever was in the second space, but if I look a little further down, I have another integer at the end of my list, so I could also add whatever my list 5, which is the number 5, and then I can still get a response there, because it knows it can add 3 numbers together. If I want to look at strings, maybe putting a couple strings together, I can concatenate strings, which means I can put them together using the plus sign, as long as everything that you're trying to put together is also a string. So if I want to print out hello space hi, I could do something like this: print my list. Where's hello? It's in 2 plus, and then maybe I'll put in the word and. Make sure you got to put, if you're using the plus sign, it doesn't automatically put spaces, so don't forget you got to put some spaces inside your quotes. So it's going to print hello, and then I also want it to print hi, which is my list 4. So in this case, it should just print out hello, and then a space, and then a space, and then hi, because it can add strings together. But what it's really doing is just putting them together back to back. Okay, so you got to be a little careful with what you're trying to do with your list stuff. Is the normal rules still apply? You can add numbers, you can do operations like division and multiplication and modulus with numbers, but you're not going to be able to do that stuff with the word hello. You know, what's hello divided by hi? It doesn't mean anything. So be aware of when you're accessing things in a list that you know what data type it is. You could use something like Boolean in here. You could use it in some logic statement, let's say. So if my list, what is that, 3? Okay, so if my list equals true, print the value of list item, list index 3 is true. Okay, so it's going to take whatever is in my list 3 and it's going to use it for logic. It's going to say, is whatever's in this spot equal to true, question mark, and if it is, it's going to print the value of the list index 3 is true. So you can use it in logic, and this is Boolean right here. And because this is Boolean, you don't even need this full statement. All you need to say is, you don't even need the second part. If my list 3, colon, print the value of index 3 is true, because my list 3 is just true. So basically all you're saying here is, if true, print value of list is true, or value of index 3 is true. Because if it replaces this with true, the whole thing evaluates to true. It doesn't even need the other part of the condition. So this will accomplish the exact same thing, and you notice it printed the exact same thing. Now, if you're using other items other than Boolean, then you do have to include the whole thing. For instance, if I want to check if the word hi is in index position 4, I would have to do something like this. If my list 4 is equal to, remember the 2 equal sign, if it's equal to hi, then print the value of list index 4 is hi. So this will check, is this particular position, my list 4, is whatever stored in that position equal to hi? And you can see it is, right? In list index 4, the word hi is there, so hi is equal to hi. It's true, and then it's going to print what it said it was going to print. So here we go. So that evaluates to true, and it's gonna do what I asked it to do, which is print this out. So you can use it in logic as well. You can use it in loops. You can use it in all sorts of things. If you just quickly want to check true or false, if something is in a dictionary, you can use that in command. So if I print 4.5 in my list, All it's going to do is it's going to look in the list and say, is there an item in there that's equal to 4.5? So 4.5 in my list. Remember, the only answers for this is either going to be true or false. It's either in there or it's not in there. So print 4.5 in my list is going to evaluate to true, so it's just going to print true, because 4.5 is in the list. If I try to check if, say I try to check if the word HI in capital letters is in my list, this should give us false, because we have high in our list, but it's lowercase. Remember, that's not the same as uppercase. So if I print high in my list, it's going through my list looking for a capital H, capital I. It will not find it because it doesn't exist in the list, so it should print false. So that's just a handy way of checking if something's in a list. You can also do something known as traversing through a list. So traversing through a list. And what this really means is goes through list item by item. If you ever hear the word traverse, it just means it's going through. It's going to check each item one by one. So let's show you how I can take a list and I can check each item and see, I can apply some logic to it. Now, because I want to have something that is easy to compare, I'm just going to put numbers in here in order to show this step. So instead of having multiple data types, I'm just going to have instead of having all the data types, I'm just going to have 2 data types in here. I think we've indicated that we understand how the indexing works just like strings. So I'm just going to make this look a little bit more normal here. Just put a couple decimals in here, a couple floats in here, so we know that we can deal with all types of number data. Okay, so my list is now just a bunch of numbers. 64 is at 0, then 5.7, 3.4, blah 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 blah. Let's say I want to check each of these list items in order and print out the ones that are greater than 6. Okay, so you can traverse through a list using a loop and check each item along the way. And what that's going to do is it's going to allow you to, no matter how big your list is, the computer can very, very quickly check each item against the logic or condition that you give it, and you can get the desired results. Now, it's very easy for me to look at my list right now and tell you which numbers are greater than 6. But if this list was 2,000 numbers, it would take me a long time to do it, and it doesn't take a computer very long at all. So we could create a simple loop to go through this in order to check all those things. And the easiest way to do that is just to use one of those for loops. So for, I'll call it item, that can be any variable name. For item in my list, okay, whenever you see the for loop, it's going to start at the beginning of the list and it's going to check its way all the way through, just like it would have done with a string. If I said for letter in, the word banana, how many A's are in it, or is this letter an A? It's going to start at the beginning of the string and it's going to go all the way to the end. So for item in my list, it'll start at the beginning. If item, okay, so when it says if item, it actually looks at whatever that item is. In this case, it's the value 64, and the next time through the loop, it's going to be 5.7 and so on. So if item is greater than 6, is the logic I just randomly picked, let's print the item, whoops, here's my quotes, the item stored the item, and then comma, item, okay, comma, and then more string is greater than 6, because that's what the logic was. Okay, so ideally, if this program works, what it's going to do is going to take each item in the list, starting at the beginning and going all the way to the end, and it's going to do it line by line. It's going to check, is the first item greater than 6? If it is, it's going to print the item, in this case 67, is greater than 6, which makes sense. The next time it runs through the loop, the second time, item is going to be 5.7, so it's going to check 5.7. If 5.7 is greater than 6, it's going to print this. Well, 5.7 is not greater than 6, so it will not run this line. Okay, so I could just leave it like this, or I could put an else in as well. So if it's not greater than 6, it must be less than or equal to 6. So I could put an easy else in here that prints the item, comma, oops, the item, comma, item, because that's the variable name, is either greater than, or sorry, less than or equal to 6. Okay, correct quotes there somewhere. There. So as it goes through the list item by item, it's going to check, is it greater than 6? If it is, it's going to print it's greater than 6. If it's not, we know it is either less than or equal to. So let's check. So it went through these are all the items that were in the list. It said 64 is greater than, 5.7 is less than, 34 is greater, 76 is greater, 34.4 is greater, and 5 is less than or equal to. So just using this quick little loop, we were able to traverse through the list or go through the list item by item and quickly separate them into the numbers that were greater than 6 or the numbers that were less than 6, or less than or equal to 6, I guess is what we knew. How can we use this in sort of a useful way? In order to answer that question, you're going to need to know how to add things to lists and how to subtract things from lists. So I'm gonna go to that next, and I'll just keep my list handy here as we continue to go through that. I probably checked through a few of these already. So multiple data types, index numbers, length, we went through that. Changing values, adding values, popping values. Okay, now we haven't done this yet. All right, so changing a list value is super easy. You just refer to the index. So let's say I want to change 5.7 to the word high. It's really easy, and it doesn't matter if you're changing it to a different data type. Doesn't matter at all. So I would just go my list and then access it by the index position. So 64 is in the 0 spot and 5.7 is in the 1 spot. So if I want to change to 5.7, I say my list 1 equals, and then whatever you want it to be. I said I'm going to make it high. So when I print this list out again, it should print out the new list. So I'm going to print out the original list first, just so we can see how it changes. So we're going to print out the original list, and then I'm going to change whatever is in position 1 to high, and then I'm going to print it out again to make sure that it's working. So here we go. Okay, so here's the original list, looks right, and then you'll notice that now 5.7 is gone from the list, and it has been replaced with high. So that is how you replace a value. Say replace or change a value. So you're not really adding a new spot to the list. You're looking at whatever's in the index position 1, or the container for index position 1, and I'm taking the 5.7 out of that container and I'm putting the high into that container. So I'm not adding another container to the list. I'm just swapping two things out. So that's how you replace a value, and it's really simple. Whatever. If you wanted to replace the third index, so that's 0, 1, 2, 3, so that'd be the 76. You just access the third element and replace that one with whatever you want. So if I do this again, the 5.7 will still be there, but instead I replaced the 76 with high. So that's a relatively simple process. Adding things to the end of a dictionary or a list is also very easy. All you have to do is use something called append. All right, so let's say I want to add 2 more things to the end of the list. I'm going to add true, and then I'm also going to add another number, 99. Sure. So the way you do that is you just identify the list that you want to add to. So my list, okay, dot append. Append means add to, and then in brackets, regular round brackets, you append whatever you want. So I'm going to append true, which means it's going to just add the Boolean value true to the end of my list, and then I'm going to add something else. I'm going to go my list dot append, and it does these in order. So because true, the append true is first, that's the first thing that's going to go into the list. And then let's say I wanted to append the number 99.99, it'll add that next. So we start with our original list. Okay, we appended 2 things to the end. You notice the original list is still there, but now it added those 2 things I asked it to add. It added true and it added 99.9. So adding things to the end of a list is very easy. Swapping things out from a list is very easy, as long as you understand how to use index numbers. And removing things from a list is actually pretty easy too. All you need to know is that the keyword is pop, right? So my list, not delete, it's my list dot pop. Don't forget the dot and don't forget the brackets. I want to pop out whatever is in position. Let's pop out the 5.7, so that's position 1. So if I pop out what's in position 1 and then I print my list again, Now we're going to have three lists. We're going to have the original, we're going to have the list we added these values to, and then we're going to have the list after we pop out whatever's in position 1, which in this case is the 5.7. So let's run it and see what happens. Okay, so original list looks good. Original list plus our 2 new items looks good. And then if you notice our list after we popped out what was in 1, you'll notice that the 5.7 is not available in this last list because in popping 1, it just pops it out of the list is what it does. Gets rid of it. The important thing to remember when you're popping something out is now all the index numbers have changed. So in the original dictionary, or I keep saying dictionary, in the original list, 64 was in the 0 position, 5.7 was in the 1, 34 was in the 2. But after you get rid of something, 64 is still in the 0, but 34 is no longer in the 2 position. 34 has been bumped forward in the list. So 34 is now the 1 item, and 76 is now the 2 instead of the 3, and 34.4 has been bumped up in the list as well. So that's important to note. So if you're looking for a certain position in the list, remember that if you pop something out, the whole list is going to shuffle back just to kind of close that gap. So it's taking an entire bin out of the storage container and then moving everything else closer to the door is what's happening. The only other mistake that is commonly made here with pop is people sometimes accidentally put the square brackets in. But because pop is a built-in function, it uses that dot notation, which all the dot notations always have the round brackets. So when we had dot append, you notice we got the round brackets, we've got append, dot append, we've got the round brackets. So that, that is an error that's easily fixable, but that does prop up from time to time. Absolutely, and we're going to get to split right away. It's right here. Okay, now combining lists, frankly, I don't have to do this very often, but it's very easy to take 2, 3, 4, however many lists you want, and combine them. So let's just say I've got my list and I've got my list 2. Okay, so my list 1 we already made. My list 2 is going to be high, and then and then it's going to be false, and then it's going to be 3.14. Okay, what if I wanted to make one list with both of these lists, or if I just wanted to print them out as one big list? I'll use a plus. So print my list plus my list 2 will print out. It won't print them back to back. It'll just print out one big list, and it always starts with whatever the first list is, and then it adds whatever the second list is after that. Now, it's important to note here that it looks like I've made one big list, but I only printed it. I didn't actually change them. So if I print out my list again, just the original, you'll notice that it hasn't been changed. Okay, I told it to print out both of those lists as one big list, but that doesn't change anything. It just displayed it that way. And now you notice when I print out my list, the original is still there. If you want to create a new list and add a bunch of lists to it, do that as well. You just have to use, you have to use the equal sign, right? So if I wanted to create a new list and I wanted to make that a combination of these two lists, then I can do that almost the same way. Just instead of printing it out, I actually created a new variable, and then in that variable I put both lists. And now when I print out all the lists, I'll print out my list, and underneath it I'll print my list 2, and then I'll print that new list that I made, which is a combination of 1 and 2. So if I new list, so you'll see when I print these, it doesn't change my list 1 and 2, but it does make a new list that combines both of them. So I have my original list, I've got my second list, and then I've got a third list that I created and saved that includes both of them. So now I can refer to new list whenever I want, and it's actually going to be both lists. And I did that without having to change the other two lists. So adding lists together is really easy. You can actually duplicate lists really easily as well. So let's say instead of having my new list be list 1 and list 2, let's just say I wanted list 1 repeated 3 times. So all I need to do there is I need to do my list and then times. So if I do my list times 3, my new list, which I'm going to print out to show you, new list, is going to be these items, and then it's just going to repeat all of those items in order again in the list. So new list is going to look like this. So you see how we've got, there's the list once, and then it just starts right back at the beginning again. There's the list twice, and then there's the list the third time. So it made a new list that basically just had the same elements repeated 3 times. So that's what the multiplication does in lists. It just takes it from front to back as many times as you want it to. And I rarely use that, but it is a simple feature. So it's very easy to combine lists. It's very easy to make new lists. Very, very handy is populating lists with loops. So especially when we're dealing with numbers, it's super easy to have Python let's automatically create lists for you that you can use. How long would it take me to write out 10,000 numbers on a piece of paper? It would take me a while, but I can have Python create a list and store, let's say the first, let's say I want a list that's going to store the first 500 even numbers. I can have Python do that and store all those numbers in almost no time at all using a for loop. So let's just say for x in range, I can't remember how many numbers I said, but I'm going to say 1,000. Okay, so for x in range 1,000, I need to make a temporary list here. So I'm going to make to do it with all the numbers that divide evenly by 4. How about that? So I'm just going to call it the fours list equals, and then I put empty brackets, which means the list is available. Python knows the list exists. I just haven't put anything in it yet. So for x in range 1,000, so it's going to start at 0 and go up to 1,000. I want to check if it's divisible by 4. So if x divided by, or sorry, percentage, that's checking remainder. If x percentage 4 is equal to 0, then we know it's divisible evenly by 4, because anything x divided by 4, if it doesn't have a remainder, that means it's divisible by 4. Numbers like 4 and 8 and 12, etc. What we're going to do is we're going to add whatever x is into the fours list. So if x is divisible by 4, then we're going to go fours list dot append, because that's how we add, and then we're going to append x. Now because we're using variables, it's going to change x every time through the loop, which means that it's going to keep adding different numbers to this list, because x is going to be different every time the loop runs. It's going to start at 0 and it's going to keep going up and up and up. And then at the end, we'll print out fours list. And that should give us a complete list of the numbers between 0 and I believe 9,999, or sorry, 999. It's going to give us a complete list of the numbers from 0 to 999 that are divisible by 4. So let's see if that works, and let's see if our data sort of reflects what we want it to reflect. It looks like it works fine, right? It did note 0. I could have started my range at 1, because 0 divided by anything is not going to give you a remainder, but I wouldn't normally say that 0 is divisible by 4. So if I start at 1 instead, I'm not going to get that 0 at the beginning, so I'll just run that again. Okay, so our first number is 4, and then 8 and 12. It's just the multiples of 4, correct? And you know most of the ones at the beginning, but maybe you didn't know that 676 was divisible by 4. So not only did it run through the loop and print these things out, because I told it to, it stored them all, right? So it stored them all in here. So that's super handy. Okay. Now, what if I want to, the fact that I've saved all these values means I can access them again. So let's say that I created another list, and I want to check which numbers are also divisible by 10. So if I go also by 10, and I make another list for that, okay, then what it's going to do is it's going to look in the original list, okay, or it's going to build the original list, and then it's going to look in that list and say, are any of these numbers also divisible by 10? So I can make a new list that I know is numbers that are divisible by 4 and also divisible by 10. So I'll just create another quick loop here for x. Now, I don't need to use range anymore because I've already got a list I can work with. Okay, so I've already got the fours list built and populated at this point. So I can just say for num in what do I call it? Fours list. So for every item in fours list, what do I want to check? Okay, now I'm checking if it's divisible by 10. So if num is divisible, or mod 10 equals 0, then I'm going to add it to that new list I made. So that new list was called also by 10, I believe. Dot append, because I want to add it to the list. And what am I adding? I'm adding whatever the num is. Now remember, this is just a variable name. I could have called it y. I even could have called it x again. Usually I like to name them so that it makes sense. So for every, you know what? I'm not even going to use num. I'm going to use item because really I'm looking at a list. I'm looking at this list of numbers, and I'm saying for each item in that list, if that item is divisible by 10, then I'm going to add or append that item into that new empty list that I created up here. And then I'm going to print off that list as well, and let's see if it makes sense to us when we look at what's included in that list. So if I print also by 10, I should now have a list of numbers saved in memory that are divisible by 4 and also divisible by 10. So it would take me a long time to do that on paper, but now I can do it just one step. So again, the steps that are going to happen when I run this program is the first thing it's going to do is creates two empty lists. Creates a divisible by 4 list, and then it creates an also by 10 list. Both of them are empty. This first loop, okay, is going to check every number between 1 and 999, and it's going to check if the number is divisible by 4. If the number is divisible by 4, it adds it to the 4s list. If it's not, it doesn't do anything with it. It just ignores it. Okay, then I print the 4s list, and then I look at each item in the 4s list in order. So for each item in the 4s list, and then I check, is this item also divisible by 10? I already know it's divisible by 4. Is that item also divisible by 10? If it is divisible by 10, I'm adding it to my other list, the one that says also by 10, and then I'm printing out that final list. So what I should see is the original list with all the numbers divisible by 4, and then after that I should see a smaller list of the numbers that are also divisible by 10. So the original list is right there, starts at 4, and then the very end of the list would be 996. And then underneath that, these are the numbers that are also divisible by 10 and 4. So this list makes sense to me because any number that's divisible by 10 is going to end in a 0. Okay? And we know that 10 itself is not divisible by 4, so 10 wouldn't be included. 20 is divisible by both, right? 20 divided by 10 is 2, and 20 divided by 4 is 5. 30 doesn't work because 30 doesn't divide nicely with 4, but 40 works, 60 works, 80 works, and so on. So the numbers that are included in this second list tell me that that worked just fine. So you've got this sort of proof of concept, and you're able to add things to lists, subtract things from lists, and you're able to use loops to big lists of numbers and do math on them. And now that I'm working for 1 to 1,000, I could do it to any number. Let's check 100,000. Hopefully this doesn't crash my computer. But let's check 100,000. So now, almost instantly, we could find all the numbers between 1 and 99,999 that are divisible by both 4 and 10, and I can do it in one click. I'm going to get rid of the 4s list. I'm just going to print out the also by 10 list. Okay, so that took no time. It was instantaneous. And I have a huge list of numbers that are divisible by 4 and also divisible by 10, all the way up to 99,000 and something, 99,980. So there's a huge list. How many numbers, you ask? Super easy to find out. Let's just print the length of that list. So let's print the length of also by 10. The length of also by 10, and we'll see how many numbers are in that list. There are 4,999 numbers in that list. Okay. So how might this pop up in sort of a testing situation? I could very easily say, I want you to create a list and use logic to find the first, say, 1,000 prime numbers. And I want you to print the list of those 1,000 prime numbers, and I want you to print out how many there are. Okay? So you would have to create the math for that. You would have to create a loop for that and find out if any given number is a prime number, which means it only divides by itself and 1. And then you would have to append those to a list, and then you would have to check the length of the list. So that's something that you could reasonably do. If you knew what you're doing, you could probably do it in about 5 minutes. And if you didn't, you could probably kind of work your way through it within half an hour or so. Let's check. I might come back to this. I just want to check my list and see if there's anything else that we need to get through. Item by item, index numbers, length, populating with loops, adding string elements to list. These two kind of go together. If you want to automatically make a list with a string, there's something called split that's super, super handy. Okay, so let's say that I have got a string, and I'll just say word equals hello. If I want to instantly turn that into a list where each letter is its own list item, Okay? It's one line. Okay, so you can actually do it a couple different ways. You could do, I'll just call it new list equals list, list word. So that's going to say I want you to make a list out of whatever's in the word, which is hello, and then you're going to save that as new list. So that will make a list. I didn't actually do anything with it. I should print out that new list. You can see what it looks like. So you can do it that way, and you see that there are 1, 2, 3, 4, 5 letters, and all of them are occupying separate places inside the list. So the 0 item would be the H, the 1 item would be the E, and so on. So it basically just took a word, split it apart, and made it into a list. It doesn't matter how long the word is. Each letter is going to get its own spot in the list. So that's a really handy way of creating a list out of a string. And another way you can do it is you can use something called split. Okay, so you can do new list equals word dot split, and by default dot split is going to split by spaces. So if we want to use to maybe say take a sentence and put each word as a separate item, I'll just say hello, my name is Brennan. Okay, if you use dot split, what it does is it looks for spaces by default, and each thing that is before space is going to have its own item. So the string hello is going to be in the 0 spot, the string my. So now it's not doing it character by character, it's doing it word by word. Okay, so now obviously I need to print that new list again. See the result. So if I want to take hello, my name is Brennan, and split that into a list, you'll notice that instead of splitting it by characters, now it splits it by word. Okay, so wherever there was a space, it knows that it should use that as the delimiter in order to populate this list. So the 0 item's hello, the 1 item's my, the 2 items name, etc. Okay? Now, it doesn't just have to be spaces. You can tell it what to look for. So let's say, for instance, you've got hello and then the plus sign for whatever reason. Okay? Now, this would just be considered one string normally. Watch what happens if I split this. If I split this, it just says, well, that's all just one thing because there's no spaces, so you only have one item in your list. But if I tell it specifically what to look for, it can split by anything. So if I specifically tell it to look for a plus sign and use that to split it up, now it's going to split it up properly. You see, hello, my name is Brennan, because every time it came across a plus, it said, oh, okay, the next thing after this plus is going to be a new item. Correct? So it's going to be the second or third or fourth or fifth item in the list. And again, it doesn't matter what you separate things by. I could separate by the character n, and now every time it hits an n, it's going to have a new list. So hello plus, and then the first n. By the way, it takes out the thing you're looking for. So in this case, it's looking for an n, which means every time it comes across an n, it doesn't include it in your list. It actually pulls it out. It's saying, this is just the thing that I'm splitting it up by. So hello, and then it runs into the n, and then so it splits it to name plus is plus Brad. Then it runs into a couple more n's, right? So it splits it. There's nothing after that, and then it splits and finds the A, and then the last thing is an N again. So the only thing it printed from my name was the BRE and the A, because all the N's were used as the delimiter. So that's split and delimiters, which are quite useful, actually, especially if you're working with strings. Very quickly, two-dimensional arrays. You will not need to use this in this class. It can make some of the final practical questions a little easier, but this is more a comp sci 30 thing. Let's just say I have a list, okay? And in that list I have, let's say that in that list I have a couple numbers. So I'll just say 4, 5, 6, 7. So I have one list here. But the thing that, something you can do with lists that's really handy is you can actually store lists inside lists. Okay, so actually I'm just going to call this one first list. Now, what if I wanted to include that entire list in another list? You can include the entire list as one item, one element. So let's say I have an integer. Let's say I've got a a float. Let's say I want to make a new list, and I want each one of these things to be a list item. All right, here's how you do it. So you can make a new list equals, and then the first item in your list is going to be first list, So it's taking the entire list and it's just storing it as one item. And then the second item in your list is going to be X, and the third item in your list is going to be Y. Okay. Now, when I print my list out, the new list, you'll notice that I've got the square brackets on the outside, but I've also got square brackets on the inside. So this entire list is just a list item within the bigger list. So you can have lists inside of lists. Let's say that X was also a list. Let's say X was a list of words, like hello and hi and whatnot. The same thing happens. You can put an entire list inside of another list. This is what's known as a two-dimensional array or a two-dimensional list. You can have as many as you want. You can go down levels. You can have another list inside this inner list. You can have as many as you want, but usually two-dimensional arrays are about as far as you go. And the only thing you really need to know about this is you have to remember that every time there's a comma in your bigger list, that's a new item. Sorry, right there. And anytime there's a comma in the inner list, that's an item of that list. So we've got this 4, 5, 6, 7 list inside the bigger list. And the question is, how do I access one specific value inside of a list that's already inside another list? Okay, so how do I access a value that's inside a list and inside one more list? You just use two sets of square brackets. So if I want to print out, for instance, the number 6, okay, I have to have two index positions to tell me where that is. So I'm going to print out, okay, the value. I'm just going to print out we are looking for. We are looking for, and what are we looking for? Here's how we access it. New list, because that's the list where everything is, square bracket. What am I looking for? Okay, now this whole thing is the 0th position of the big list. This whole thing is in the 1 position, and this 5.4 is the 2 position. So I'm looking inside the 0 position. So that's the first thing I need to put in. I want to look inside the 0 element, which is this list. And then that's also a list. So I want to look inside that list. And because I want to hit the 6, that is the 0, 1, 2. That's in the 2 spot. So if I access from new list the 0th element, which is that whole thing, and then inside that I access the number 2 element, I should have it narrowed down to the 6. And what it should print is we are looking for 6. So if you're looking inside a two-dimensional array, you just have two sets of brackets and index numbers back to back. And it always works from the outside in. So the first number is always going to be the biggest list, and then the next number is going to be one of the lists inside. And you could go 3, 4 levels, whatever, but usually you would only need 2 for any given situation. So if I print this out, it should say we were looking for 6, and it does. So that's how you can operate with two-dimensional arrays. All right, that's about an hour and a half. That's plenty of learning today. Lists and dictionaries are very important, but certainly lists are much more important for the remainder of this course and our programs and the practical portion of the second Python exam. Definitely know how to work lists, and everything that is included or required for that second exam, I have gone through today. As always, if you got any questions or if I went through something a little quickly in the video and it didn't make sense, just let me know via email. I'm happy to work with you on it. But if you go through this video and practice some more on your own, either the ones that we went through, or if you create some sort of ideas of your own, say I'm going to try and find out what the first 1,000 numbers are that are divisible by 7. You can make up your own little programs or challenges to make sure that you understand what you're doing. And as well, assignment 13 is going to require a lot of work with lists. So that's, sorry, assignment, yes, 13, where it's the assignments for 4.6 and 4.7. You're going to need to use lists for just about every one of them. So you need to understand them well. We'll probably do a quick review and maybe just tackle a couple of challenges using lists on our next session, which will be on Monday. And then we'll move on to the final concept, which is 4.8, which is try and accept, and what we call sanitizing inputs. And then that's the last Python things that we need to know to complete the second Python unit exam, to complete the last assignment from 4.6, 4.7, and also to complete all of those codingbat.com programs. So I think that should take us pretty much to the end of the course. Have a nice day.